Aboard to the first session of magnetism, where we're going to talk about Biot Savart's law, field due to coils on the axis as well as at the center, and also learn how to calculate field due to wires carrying current. So this is our first session of magnetism. We have successfully completed electrostatics, current, electricity, Gauss law, as well as capacitors. So time to move on. Welcome, my lovely warriors. Hi Ankit, hi Sai Telugu. Hello Insane Asylum. What names you guys come up with? Hi Chinna Kakka Mutai. Wow, such a big name. Hi PL Windbone, nice to see you back. Hi Jyoti. Hello Munna, by MBBS or engineer. Okay, so welcome Sai Telugu. Vanakkam everyone. Shrinu, CSK fan club, Tarun, Ankit, Uncharted, long time. Money, hello Nitish. When will they release CBSE class 10th result? I don't know, man. I'm not in the ministry, nor am I involved. Nobody knows. We are just waiting for that, just like you. Hi Vikram, good evening. Let's rock it. Yep. So, for those of you who do not know me, I am Shreyas and I'm the physics master teacher at Vedantu. I have been teaching, like you can see, for almost, guys, more than 10 years. And I not only teach on the YouTube platform, but also on the regular platform. In fact, I have made a video on what are all the different micro courses that I am conducting for 11th and 12th. So if you are in the pro subscription, in fact, you can directly enroll for free of cost in these courses. And many of my students, I am really proud because I always try to mention this because it makes me proud. A lot of my students are in IITs, NITs, BITS, I mean, you name it, guys. And many of them have even got 2-digit All India ranks. And that's why we are here, so that we are going to crack JEE 2022. And how many of you are going to crack it? Let me know in the chat box by putting up a yo and saying JEE 2022. We are going to rock it. Yep. Hello, Danida. Hi, Surya. Welcome aboard. Yep. And oh, some of you are new to the live classes. Welcome. And some of you have also seen the recorded classes. So guys, yes, it's always fun to be in a live class. You get your names called out when you answer and you post up something nice. Definitely I'll call out your name. And do not forget that live classes are always interactive, and in recorded you always stand up to either fast forward or probably miss out on some important things. So it keeps you pushed towards the current state rather than covering up and doing your backlogs. Yep. Oh, some of you are NEET 2022. Thank you for all the love from Tamil Nadu. And guys, if you want to know more about me, definitely ping me on my Instagram handle, Shreyas_Vedantu. Well, a lot of things coming up. By the way, this timetable is going to change, so no point discussing it. Remember one thing, those of you who are joining the pro subscription, alright, there's a very important announcement, and that is something what Vedantu is making for all of you, and that's a promise. VIP, Vedantu Improvement Promise. It guarantees you that your rank is going to improve. Your performance is going to improve. If you are at this stage, you're going to be at this stage. If you're at this stage, you're going to be at that level. So, no other coaching gives this guarantee. Vedantu gives this guarantee, and we tell that, we are going to return back the fees if you do not improve. So, that's a big advantage. So all those students who are preparing for the 2022, be it JEE, be it NEET examination, you should definitely check out our pro subscription, because if you are a pro user, there is a good chance that you will perform better than the other coaching, or students who are not studying in Vedantu. Like you can see, the 12th board results last year were 5 times higher, 5.2 times higher than the national average. The advanced clearance rate is 6 to 7 times higher than the national average. So this is what gives us the confidence by these amazing results. And the packages for the pro subscription start as low as 3,060 rupees per month. I mean, that's very cheap, guys. And you can avail additional facilities like doubt solving and personal mentor in the other ones, and they are also very affordable if you compare it with any other coaching institute. And remember, you have to use this coupon code SHHPRO to get that 10% off. Okay, so let's begin with the first talk for today, and that's Orsted's experiment. How many of you have heard about Orsted back in your 10th standard? Let me know in the chat box. Oh yeah, PL is missing some of their older friends in Enthuse. Yes, PL, because most of them are now in pro. Like if you remember Kirito and so many others, Right now they are in pro subscription. That's why they are not getting time to attend YouTube and pro together. I'm very good, Srikanth. Thank you very much. Okay. So what he did was, he thought, can current produce magnetic field? He performed a lot of experiments and he found out that yes, indeed it can. And he was basically a Danish, physicist. Yep, he did that experiment where he passed on current through wires. He had those magnetic needles and he saw they got deflected. I'm going to show you a cool animation, a live experiment based on that as well, so that you can see how exactly he did it. And he saw that whenever current passes through the wire, the magnetic needle deflects, and if the current direction reverses, the deflection also reverses. That was an interesting thing. That means the direction of magnetic property which is created around a wire. So a wire carrying current creates a magnetic property around it, and there is magnetic field around it. So whenever a wire carries current, it produces magnetic field. That was his first observation. Second observation was, if the direction reverses, the field also reverses the direction. No current, no deflection. That shows that there is nothing magnetic around it. It does not behave like a magnet. That's what he saw. In fact, he also saw this. If you pass more current, the deflection was even higher. More the current, more strong the field was. And he also saw this. If you take that deflecting needle far away from the wire, then the deflection reduced. That means as you go far away from that wire, the strength, the intensity of that magnetic field also reduced. That's what he saw. Yeah, Miss Attitude, you can listen. Although there are a lot of similarities between electrostatics and magnetism, I would highly recommend all those people who are joining in late to please watch the replays of the previous sessions in our playlist. It is there all in our channel, guys. Please watch it. Do not say, sir, can you cover it in one shot, sir? Guys, there is a lot of time. You can still cover your backlogs. Please do that. Do not ask me to do, sir, one shot may please cover electrostatics, Gauss law. You know, then I'll have to skip so many things, right? So there is no point. Yes, but I will plan something very special to revise electrostatics, current, electricity and capacitors very soon. You will know what it is. In fact, this Thursday I'm planning 6 to 5 hours of marathon for the 11th standard kids. And I'll plan something like that for you guys for revising all the previous chapters. How about that? Will it not be cool, guys? This Thursday I'm planning to do that. In one shot, revise all the previous chapters for 11th standard till date, whatever I have covered, like units and dimensions, 1D and vectors and all of that. And similarly, I'll do something like that for you guys very soon. So stay tuned, guys. Don't worry. Okay, let's do it. Okay, great. Okay. A lot of hearts and a lot of smileys out there. Thank you guys very much. Okay, now having said this, this is how the experimental setup looks like. Look at that. See, this setup, all right, if you complete the circuit, you can see the needle gets deflected. If you remove that circuit, there is no deflection. It does not get deflected. It will be pointing usually towards the north, which is the Earth's magnetic field's direction. The moment you complete the circuit, the current flows in that wire. So this is that wire. That wire produces magnetic field around it. Keep this in mind. So that produces that deflection in that coil. Okay. Now we have been talking about field very often. Don't worry, Chinna, you will not get blocked. And if you get blocked, let me know by some other account or on Instagram. I will unblock you and I will make sure that you are not blocked. Okay, don't worry. I'll just check it out. Settings here. Okay. Now here is the thing. Remember electric field. The symbol was E bar. In magnetic field, the symbol is B. It's a vector quantity. Obviously, it has both magnitude as well as direction. So it's a vector quantity. What is the direction? We'll talk about it very soon. Don't worry. But remember, any magnet has magnetic field around it. Like you will see the magnetic field lines coming something like this. These are the magnetic field lines coming out of a horseshoe magnet. This is the magnetic field lines, something like this. It will also come from here to here and like this. These are the magnetic field lines. Similarly, a bar magnet. How many of you have done this or seen this experiment? The magnetic field lines you sprinkle some iron fillings, you take a bar magnet, sprinkle some iron fillings, tap it. You will see those iron fillings being magnetic in nature. They arrange themselves beautifully in those paths just to show you how the magnetic field around it is. Yes, 10th class experiment. Beautiful. Yes, Bhargav. Correcto. Yep. So, okay, I got your point. Admin blocked me. I'm me Enthuse. You made your point. Don't worry. All right. Thank you, Avila. Abhi Shah. Okay. Yep. Don't worry. Sir, why is it called horseshoe magnet? Because, actually speaking, the shape of that, the shoe which is fitted on the feet of the horse looks like this. So the shape of this is of the shape of the shoe which is fitted on a horse or those animals. That's why it's called horseshoe, and it is a magnet. That's why horseshoe magnet. Okay, cool. Now remember one thing. Okay, this is measured in Tesla. That's the unit. Remember that. Tesla, the very famous car. How many of you love Tesla cars? Please let me know in the chat box. And how many of you want to become a very, very successful person one day and buy a Tesla car? Please let me know in the chat box. And for that, you need to study really well. Clear your JEE exams, clear your NEET exams, clear your all the entrance examinations, guys. That's your first step to buy a very cool car like Tesla. So that's, by the way, this Tesla is in the honor of not the current Elon Musk's company. Okay, it's not for that. It's based on, it's an honor to Nikola Tesla, who was a very famous scientist, physicist back 100 years back or something. Yep. Okay. Oh my God, who is that? Cars are boring. Looks like for you, bikes are exciting. Okay, cool. Let's see. No problem. Now that I told you that magnetic field B is a vector quantity, it has magnitude and direction. Let's talk about that law which gives you both the magnitude and the direction of the field because of a current carrying wire. Now try and remember, due to a point charge Q at a distance of R, what was the field? The field, electric field, charge ke wajah se the field was, remember, 1 upon 4 pi epsilon naught, alright, Q divided by R square, and we had R hat over here. That was the unit vector in the direction of that distance, the position vector. This was the electric field. You will see the magnetic field formula is very, very similar to this. That's the reason why I wrote this. You will see why. Okay. Now, look at this. This is a wire carrying current, some curved, some random wire. Don't break your head over it. Each part of that wire will produce magnetic field. What did I say? This wire is carrying current. What will each part of the wire do? It will produce magnetic field around it. If you are far, it is less. If you are close, it's more. If the current is more, field is also more. Now, where are you? You are here. You are here. You want to know what's the field because of this part, a small part of that wire. What is that DL? I'll just write it down over here. This DL is an element. It's a small element which carries current. Do you see that? This is your current. There is some current which is flowing in this part. I am at this distance. This is my position. Okay, this is my position. This is where I am. And I want to find what is the field here. What is the field here? Because of this small element. Because the small element's length is dl, that's the reason why the field is dB and not B. dB stands for field produced by a small element. Is everybody understanding this? Oh no, it's not a very strange law. It's very simple. It comes by Coulomb's law. Force by charge, you get this. 1 upon 4 pi epsilon Q by R square. This is just unit vector. It won't affect the magnitude. Okay, correcto. Now, that field formula is given by this. Okay, before going ahead, let me just mention one more thing. This vector, do you see over here? This vector, if you see over here, this is a unit position vector. Unit position vector, that's all. Position vector points the position where you are with respect to that element. Unit vector means magnitude is one, direction is in the same way as where it is pointing. That field is given by dB. Look at this, guys. Look at the similarity. You will be astonished to see the similarities between both of them. Trust me on this. So it is nothing but, instead of 1 upon 4 pi epsilon naught, you have 1 upon 4 pi. Instead of 1 by epsilon naught, you have just mu naught. Now what is this mu naught? Hold on, don't worry about it, I'll tell you. Instead of Q, yes, instead of Q, guys, you have I, which is the current dl vector, and divided by r square. Again, yes, you have r square below, and there is a cross product with r hat vector. That's it. That's the only difference. Because I have put dl vector, I cannot just put r bar. There has to be some symbol. That symbol is cross product. This is an experimental law. This has been found by these people via experiments. Okay, so this is a very, very important equation. Now what is this mu naught? Mu naught is permeability of free space, of empty space, vacuum. And this value is very similar. You can remember it, guys. 1 upon 4 pi epsilon naught was 9 into 10 to the power 9. Here mu naught by 4 pi is 10 to the power minus 7 in SI units. So if everything is in SI, this is in Tesla, this is amperes, this is in meters, then this value is 10 to the power minus 7. No, r cap cannot be in any direction. Be careful, Vikram. R cap is in this direction. Unit position vector. This is that unit position vector in that direction. Be careful. What does dB represent? The field due to the small element. The field due to the small element. Okay. Now, what is this? Basically, this tells you, this mu naught. What is this mu naught? Permeability of free space. Remember epsilon naught? It used to tell how permissible the field is. Different medium had different epsilon naught, different permittivity. The field strength used to change in different medium. We have talked about dielectrics. Don't you remember that? So same way, you will see different materials will allow different amount of field lines through it. So the permeability, how much can it permit, is different for different medium. So for vacuum, mu naught by 4 pi is 10 to the power minus 7. I hope this is clear. Yes, everybody understanding this? I hope this much is understood. Now, look at this cross product. Look at this cross product, guys. The direction of the field is given by dl cross r. What is the direction of dl? The direction of dl is same as of current. Same as the current's direction. Where is the current flowing? There. So dl vector is in that direction. Everybody keep this thing in your mind. Dl vector is in the direction of the current. Position vector. The position vector, I just told you, it points to where you want to find the field with respect to this element. So position vector is here. dl is here, r is here. Cross product. Do you remember A cross B? I have told you, use your curled fingers, guys. Use your curled fingers. Yes, curl your fingers. Remember, first it goes in the direction of A, then it goes in the direction of B. The thumb points in the direction of A cross B. I hope you remember, yes, your right hand thumb rule. So first A, which is dl, then r. Oh, I cannot go like that. So I'll have to turn my hand. I turn my hand like this. dl cross r. Don't go like this. That would be stupidity, right? Obviously, you have to go by the shortest path. dl, r. So 4 fingers in the direction of dl, then cross r. Where is your thumb going? It's going, look at the thumb is going inside. That's why the magnetic field is inwards at this point. I hope this is clear. Everybody understood? Everybody understood how to figure out the direction? It's just nothing but the first chapter, second chapter which you study in physics, cross product. So if you remember how to find cross product of any two vectors, you can get it very easily. It is inside the plane of the board. Hello Ramcharan, welcome aboard. Everyone welcome. Yep. So if you guys have understood, let me know, because don't worry, all these things which I have just told you, it's all there out here. It's all there out here. I have put it up as theory slide. Don't worry about it. One last thing. Don't you see, guys, every element will produce a field over here. Every element will produce a field over here. So the field due to the entire wire, what will it be? It will be the sum of fields due to each element. And what is the field due to each element? Well, that's dB, and sum of such terms will be integral. So it is basically integral dB. That's it. That's it. That's all it is. It's integral dB. Thank you, Kirti. Okay, everybody understanding this? Shall we go ahead? Shall we go ahead? Let's do some questions on this. Welcome all the new members to the Warrior family. Yes, thank you guys for welcoming everyone. Okay, let's do this. Let's do some questions. Keep all these things in mind. Mu naught by 4 pi 10 to the power minus 7. Keep this law in mind. Very similar to electric field, you would have seen that. And total field is always the integral of all the individual fields. Let's see if you can do this question. Okay. And yeah, oh, I thank you, Giojos, for reminding me. By the way, I forgot to tell you all this. Guys, a sincere thanks to all of you, all the warriors, all my lovely minions, for making us grow beyond 50,000. This is just the beginning, guys, let me tell you that. But this milestone, this achievement wouldn't have been possible without you being here, without you guys tagging us, promoting us, without you guys recommending us, sharing, liking, watching all our videos. Without your comments, without your support, this would never ever be possible. So all the credit goes to you for making us grow. We were always there, we used to always teach, but coming on this platform and making this channel popular, this is a very unique channel because there is no other English channel that I know of for JEE. So this is an exclusive JEE English channel for all the people who are studying in English medium. So thank you guys very much, and next milestone is 1 lakh and we'll reach there very soon. Okay, chalo, let's do this question. This is a wire carrying current. This is also wire carrying current, but what's the direction of the field? Let's look at this. I'll tell you what you should do. See, current is here. Remember, the field's direction is always in the direction of L, alright, L cross R, direction wise, L cross R. So length vector is here, current is going in this direction, R vector is here, R vector is here. So L, first put your 4 fingers here, cross R, L cross R. Where is your thumb going? Where is your thumb going? It's going inside, right? So because of this wire, the magnetic field is inside. I hope this much is clear. Everybody understanding this? Great. Now, think because of this wire what will happen. The current is going here, so length vector is here. The position vector is here. This is your position vector. So L cross R, do not do that. That would be stupidity. L, put your 4 fingers up, the palm facing towards you. L cross R, very easy. Where is the thumb coming? Towards you. So at that point, the magnetic field is towards you. So it looks like there is inward and outward field, but will they not cancel each other or what? Oh, there is a catch. You can see this. Currents are different. This current, look at that, I2 is more. I hope this is clear. I2 is more. I2 is more means who is more? This one is more. This one is more. This one is less. So hence, which direction is the net field? The net field is in outward direction towards us. Correct. Ankit, that's the value. Ankit, mu naught by 4 pi comes out to be 10 to the power minus 7 in SI unit. Just like, you know how 1 upon 4 pi epsilon naught came out to be 9 into 10 to the power 7. These are experimental constants. Understand that. Okay. Okay. So, Kusuma Bhargavi, for 2021 students, you have the you have the rank booster series and also the 0 to hero series. So both these series, and once the dates are announced, we will start the mock tests as soon as the dates are announced. Okay. What is the direction of the magnetic field at this point P? Remember, this is a curved wire. This is like a curved wire. Yes, come on. Giri, 9 into 10 to the power 9 for 1 upon 4 pi epsilon naught. 10 to the power minus 7 is for magnetic field. Okay, come on, my warriors, think about it. Again, all you need to do is remember each field will be in the direction of dl cross r. That's all you need to think about. So if you take any element over here, the current is going in that direction. So that is the direction of dl. Where is r? R is here. Okay, just do dl cross r. dl 4 fingers, put your 4 fingers here, then cross r. Where is your thumb going? It's inside. Yes. Now you might be wondering, sir, what about this element? What about this element? Guys, you can take any element that you want. This is your dl, this is your r. Do dl cross r. dl cross r. It goes inside. Take this element also if you want. Okay, this is dl, this is r. Just do that. dl over there, r over here. Where is your thumb going? It's going inside. So each element is adding to the field, hence the net field is going to be inwards. So the final answer is inwards. Everybody understood? Very good. So get the directions correct, only then you will understand everything else. Let's see if we can solve this question. Two perpendicular wires. This wire is going like this wire is going like this, and this wire abruptly ends here. Yes, this wire, horizontal wire, ends here. And on that line, you have a point P. On the same wire's line, you have a point P. What's the direction of the net magnetic field because of these currents? Think about it. Come on, my warriors. It should not be difficult. Come on, think about it. All right, let's see. First of all, let's see because of this wire. Okay, because of this wire. So the current is in this direction, that's dl's direction. R vector is over here. So just do dl cross r. dl is up, r is here, fingers go inside. So the thumb goes inside. So it should be like this, inside the plane. But what about this wire? Oh, this is a very interesting thing. My dl vector is over here, in this direction, in the direction of current. My r vector is also over here. Check this out. My r vector, the position vector, is also over here. So what is the cross product of dl cross r? dl cross r will be 0 because the angle is 0. Remember, cross product has AB sine theta. Sine theta is 0 because theta is 0. Because both the vectors are in the same direction, there is no angle between them. Hence, there is no contribution. No contribution over here by this wire. So remember this. Whenever there is a point on the line of the wire, the contribution of the wire's field will be 0. So whenever there is a point on the wire in the same line, collinear, then the contribution because of that wire will be 0. So there is only one wire which is contributing, and that's the one over here which is vertical, and it is inside. So hence the net answer is inwards. Yep, that's how it is. Very good. So guys, if you have understood till here, shall we take the first geometry for today? Because the first geometry is a coil and the second geometry is a wire. We are going to solve lots of problems so that you guys are going to become experts tonight on these topics. So let's get going. Thank you guys for all the love. Thank you guys for all the support. Thank you guys for keeping the chat box alive. And in case you have forgotten to smash the like button, please do that now. And if you are new to the channel, do not forget to hit the subscribe button there. Okay, now look at this beautiful diagram, guys. I love this diagram. Look at that. This is a ring or a coil which carries current, the red one. The one in red shows the direction of the current. The one in green shows the magnetic field lines. It shows the magnetic field lines. So what is happening over here is basically, I'll tell you what, every element, let's say this element, if I call this as an element, this element at any point, let's say here, if you do dl cross r, if you go dl cross r and the rest of the things, mu naught I by 4 pi, and then you have, this r square and all of that, that gives you the magnetic field due to this element at this point. Each element over here at any point is producing magnetic field. So This element produces some magnetic field here, this element will produce some magnetic field here, this element will produce some magnetic field here. The total magnetic field is what is shown on the board. This is the total magnetic field lines, and this is very easy to remember. Yes, it's very easy to remember, guys. I'll tell you what you should do. Some people forget, sir, should it be up or should it be down? Sir, what if the direction of the current changes? Obviously, if the current goes other way, the field lines, instead of going like this, they will go like that. But how do you remember that? Very simple rule. Come on, everybody who has the right hand, put up the right hand in the chat box. Please do that. Yeah. If you have your right hand available with you, please put your right hand in the chat box. Okay. Just kidding, guys. Okay. So what you need to do is take your right hand, curl the fingers in whatever is rotating. What is rotating? The current. The current is going around. The current is going around. Yeah? The current. Okay. Okay. Everybody has the right hands. Amazing. Hi, Nia. Welcome aboard. Now see, where is the thumb going? Where is the thumb going? It's going like this. So the magnetic field lines will be like that. If the current went like this, then you take your fingers. It's a little bit difficult. Curl it like that. Curl it like that in the direction of the current. Curl it like that. You will see, where is the thumb going? It's going down. That means the field lines will go like this through the ring. Is that now clear? Oops, somebody put their left hand. Okay, everybody clear about this? Yep. So that's all you need to do. That's all you need to do. Yep. You would have studied this in your 10th standard also, maybe. I don't know. Okay. Now, what is the direction of the field? We just figured it out using right hand rule. That is what I just told you. So all you need to do is curl your fingers in the direction of current. So you can see in both these cases, either you can hold it like this or you hold it like this. The thumb's direction does not change. Please understand, both these diagrams are same only, actually speaking. You hold it like this or you hold it like this. It's one and the same thing. It's one and the same thing because the thumb goes in that direction. If everybody has agreed to this point, let's go ahead. It just looks different. Sometimes this might be convenient. Okay, sometimes this might be convenient. Understand that. Yeah. Now, let's figure out the magnitude of this. So, here is the thing. The logic goes something like this. Simple. Now, let's talk about the magnitude. This is very important. See, if you take any element, okay, this is an element, and the current goes like this. So, this is my dl vector, and this one is my position vector. Okay, guys, think about it. dl vector is along the circumference, r vector is along the radius. What is the angle between them? Come on, answer it in the chat box. Thank you, Dadi Divakar. Oh my god, what a name. What is the angle between dl and r? No problem, Ishan, you can just wind up a little bit. Yeah, just watch whatever I taught initially and probably you can catch up at 2x speed. Yeah, 90 degree, beautiful, excellent. Eh? So it's 90 degree, very good. So what is the direction of the field over here? Okay, this is going to be crazy, guys. I mean, like dl, I'll just hold it like this. So as if I am a student, I'm going to put my right hand slightly towards the left. dl cross r. Where is it going? Where is my thumb going? It's going up. So yes, the db vector will be like this. Every element will produce dB. Every element will produce dB in this direction. So at the center of the coil, the net magnetic field will be just the addition of all the dBs. No splitting, no resolution required, because all the dBs, all the dabbas are in the same direction. All the dabbas, all the dBs. Just kidding, okay? So all the dBs are in the same direction. Okay. So what is the value of that dB? Well, it's mu naught by 4 pi. I is the current, dl is dl, r hat, okay, r hat's magnitude into, remember this, R hat is always needed. That's how the Biot Savart's law was, I dl cross R into sine 90. Why sine 90? Because cross product means AB sine theta. So theta was 90 degrees divided by R square. Remember, on the top you always had that unit vector. So what am I going to get? A lot of people are constants. This guy, I, even R square is constant, guys. Yep, R square is constant because the distance of any element is the same, isn't it? So all these people are going to come outside. R hat, what is the magnitude of R hat? It is nothing but 1. Sine 90, 1. Only dl will remain inside, bichara. Only Papa dl is going to remain inside. So mu naught I by 4 pi R square is outside. Only Papa dl is there inside. Now what is dl? Integration. dl plus 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 dl. What will you get when you add all the dl's on that coil, guys? Let me know. Very good, HSR. Kya baat hai? Nice to see you. Okay. 2 pi r square. No, 2 pi r. Yes, only 2 pi r. Correcto. This is going to be your circumference. Yes, circumference. Correcto. So that means you will get mu naught I 2 pi r divided by 4 pi r square. Now what do we do? R and r gone. 2 and 4, 2. Pi, by. Okay, so what did we do get now from here? We will get B is equal to mu naught I, okay, nothing else, divided by 2r. That is my final formula. Yes, there we go. I hope this is clear. I hope this is clear. Isn't it interesting? So this is the formula which you are going to remember. Mu naught I by 2r. Mu naught I by 2r. Yes, full circle. Yep. Mu naught I by 2r. Remember this. Now, very interesting things in this formula. Don't worry, all these derivations you can watch it later on also. Remember one thing. This B, which I just got it as mu naught I by 2r, it is only for one loop. Yes, it is one loop only. But if there are n number of loops, that means 1, 2, 3, 4, you put a jalebi over there. Yes, you put a jalebi. Everybody knows a jalebi, right? So if you have n loops, all you need to do is every jalebi's turn will give field. They will all add up. So you just put n over there. That's it. N number of times. That's all. That's it. Okay, great. Now, sometimes there could be some interesting question like this. Instead of the entire loop being there, only a part of the loop might be there. Yep, only a part of the loop might be there. This is theta, this is current, and they will ask you, what is the field at this point? What is the field at this point? First of all, figure out the direction, guys. What is the direction? Remember, curl your fingers in the direction of current. Curl your fingers, 4 fingers in the direction of current. See, where is the thumb coming? Towards you. That means the magnetic field will be towards me. Okay, towards me. What is the magnitude? Guys, the logic is simple. The logic is simple. This mu naught I by 2r is the formula for a complete loop. This is only a part of the loop. What fraction is this? What fraction is it? Think about it. What fraction of the loop is this? Isn't this theta by 2 pi? The entire loop would have a total angle of 2 pi radians. This loop, this arc has only theta. So fraction wise, isn't it theta divided by 2 pi? That's the fractional part of that thing. So if the entire loop creates this much field, this much part will create mu naught I by 2r, r is the radius, into that fraction which is theta by 2 pi. That's it. That's the answer. That's all you should remember. So this fraction, if it is half, that means it's a semicircle, then this should be multiplied by half, because each semicircle will contribute to half field. If it is 90 degrees, then it is 1/4. Correct? It is 1/4. So you multiply by 1/4. So 1/4 part is the contribution of the entire. Yes. I hope this much is understood. Okay, cool. Shall we go ahead? Great. Guys, come on, focus on the class. Do not try to put anybody else down. Make sure you motivate others. Remember, we are a lovely family. You should never ever insult, demean others. You should always try to help. Have that compassion. Guys, understand, none of the people over here are your enemies. Your competition is not with 10 lakh, 15 lakh, 100, God knows how many other people are there in any institute. Remember, the competition is always with you, and that too yesterday. Who you were yesterday. Are you better than what you were yesterday? Well, if you're not, then you're losing in the competition. No matter what your rank is, guys, even if you're the last person, even if your percentile is 0 percentile, I don't care. But are you better than what you were yesterday? If not, then you're not improving. Remember that. Okay, chalo, let's get going. Let's solve some very cool problems out here. Okay, so all the derivation, whatever is required, I have put it up here. Don't worry about it. Where is it? Yes, let's see how many of you can get this question. Okay. There we go. A circular coil has one turn. Okay, it has only one turn and it carries current I. Now the same wire, so you unwind it and you make 4 turns out of it. So if you pass the same current, what will be the new field at the center? Will it be 4 times less? Will it be same? Will it increase 14 times or will it increase 16 times? Think about it. Very interesting question. Come on guys, figure this out. It's not that difficult. Come on. You take the wire, you unwind it and make 4 turns out of it. So what will happen? What will happen? Think about it, my warriors. Think about it. Come on, my warriors. B, same? Okay. Let's have a look. Here is the answer. What you need to do is, when you have a current carrying loop, this is R, and you want to find the magnetic field, it is mu naught I by 2R. This is the formula, correct? Now, when you make 4 turns out of it, you might think I should multiply the numerator, alright, I should multiply the numerator by 4. Correct, the current gets multiplied 4 times. But what about the radius? The current into 4. Why? Because there are 4 turns over here. What about the radius? Even the radius will become smaller. Think about it. What is constant? The thing which is constant is the length. The length of the wire is constant. So in this case, the length of the wire was 2 pi r. That's the length of the wire. But in this case, the length of the wire will be 2 pi new radius but into 4. 2 pi r, 2 pi r, 2 pi r, 2 pi r. That's the total length of the wire. So don't you see that the new radius is actually the old radius divided by 4? It has become 4 times less. So shouldn't I multiply this by 1 by 4? Don't you see that, guys? Hence, this 1 by 4, when that 4 goes on the top, 4 and 4 will get multiplied. So it will become 16. So the new field will be 16 times more than the previous value. Understood? Everyone? Yes, correct, Aishwarya. The radius will reduce to 1/4. It will not be the same. Many of you got the answer as B. Yeah, there you go. Let's do the next question coming up on your screen now. Beautiful question. Beautiful question. Let's do this beautiful question again. This is 1/4 of a circle. This is 3/4 of a circle. The current from the battery, which is I, comes over here. It gets split. 1/4, 3/4. Okay, the current gets split. This is 1/4 part, this is 3/4 part. Again it meets and comes over here. So this loop will produce some field at the center. The question is, what is the field at the center? Remember, the wire is uniform, the ring is uniform. Thank you for all the love from Pondicherry. Windbone says D, Ankit says A. I don't know. What's the answer? Let's see guys, come on, figure this out. The current comes here, splits. Each arc will produce magnetic field. What will happen? What's the magnitude? What's the direction? Think about it and then add them up and see which of the options will match. Okay, a lot of you are saying D. I don't know. Let's figure this out. Guys, isn't this like a parallel circuit? This is one resistance. This is three resistances. If this resistance is R, okay, if I put this as, or rather X ohms, this will be X, X, X. So isn't this 3X ohms? Isn't this like a parallel circuit? This is like parallel circuit. So what happens in parallel circuit? I have told this very clearly again and again that the current divides in the inverse ratio of the resistances. Yes, it divides inversely in the ratio of the resistances. So if this is X, this is 3X, the current here will be I and here will be 3I. Understand? So total current will be 4I. Think of it that way. Yes, the current will get divided in the inverse ratio of the resistances. Once you get that, think what is the magnetic field because of the 3/4 circle. Because of that 3/4 circle, what is the magnetic field? The formula is mu naught I by 2R. Remember into that fraction. What fraction of the complete circle it is? Obviously it is 3/4. So do not forget to multiply by 3/4. Isn't it clear? And what is the direction of the current? It is going like this. So curl your fingers clockwise. See where your thumb is going. I think it's going inside. So the magnetic field is inside. Okay. So because of the 3/4 part, mu naught I by 2R and into 3/4 because it is 3/4 of the complete circle. Similarly, what's the magnetic field because of that quarter circle? Well, it's again mu naught. Current is 3I. Yes, the current is 3I by 2R. And how much part of that big circle it is? It's 1/4 part. So into 1/4. Now, once you got the magnitude, check the direction. The current is going like this. It's going like this. See where the thumb is coming. It's coming towards you. So I should put a dot over here. Now what will this cross and dot do? Cancel? Will it cancel completely? Yes, the magnitudes are equal. Hence the answer is 0. Yep. I hope this is clear. So both the magnitudes, you can check it out. Mu naught 3I divided by 2R into 4 divided by 2R into 4. Magnitudes are equal and you can see the directions are opposite. So they will definitely cancel out each other. Isn't it interesting? Yep. So that's why the answer is 0 guys. Beautiful question. Amazing. So when the current splits, be careful that the fractional part will be different, the currents will be different. So you need to account for the directions, the magnitudes, the fractional part, the currents, and then solve this question. What a brilliant question. Now let's move a little bit ahead and let's see what would be the magnetic field on the axis. We just figured out what is the magnetic field here, and that was mu naught I divided by 2R into N, where this is number of loops. Okay, now think about this. What will be the magnetic field somewhere here? This is the axis. This is my axis, guys. What about the field here or here or here or here? So that's what we need to figure out, and let's see what is that. Now here is the thing. When you are on the axis of a coil which carries current, again go by the same method. Due to each element, try to figure out what is the magnetic field. Let's do this. Okay, there is an element which is coming towards me. This is dl. Position vector. This is my position vector. My r hat will be here. This is my position vector. This is my unit vector. Try to visualize this. Think of a ring, horizontal. Okay, think of a horizontal ring. This is the vertical axis. This dl is here towards you. This dl is towards you. Keep this in mind. This r is like that. It's pointing towards wherever you want to find the field. Let's assume that this height or this distance from the center to this point is x. This one is obviously the radius of the ring, which is r. Obviously, this is perpendicular. Please understand, DL is actually coming towards you. Just try to visualize this in 3D. My question to you guys is, what is the angle between r hat and DL? What is the angle between r hat, that position vector, unit vector, and this DL vector? Try to visualize this. I'll just show you over here. R vector is like this, dr vector is towards you. Remember, the axis is somewhere like that. The axis is somewhere like that. That red vector is at an angle. This DL is coming towards you. What's the angle between this red vector and my pen over here? What's the angle? Come on. Windbone says 90. Surya says 90. Thank you for all the love from Nepal. Hi Jones, welcome aboard everyone. VK, everybody seeing 90? Yes, don't you see it's 90 degrees? You can clearly see if I hold the pens like this. Excellent. So, this angle, okay, is 90 degrees. This is 90. Now, try to do DL cross R. Yes, let's try to do DL cross R. Think about it. DL is towards you, R is here. You have to use your right hand. So DL, you have to hold, this is your right hand. Hold it like this. Everybody hold it like this, as if you're carrying some vada paos or something. Yeah. Hold it like this. And just curl it like this. Just turn it like this. DL cross R. Don't you see the thumb comes this way? Look at that, thumb comes this way. DL cross R, the thumb is this way, guys. DL cross R. That means it points in this direction. It points like this. Yep, it points like this. So that's what it means, that the magnetic field at this point will be here, dB vector. Think about it. And this is obviously going to be 90 degrees. Everybody understood this point? Everybody understood this point? Everybody clear about this? So DL cross R comes out this way, and that's the direction of the magnetic field over there. Now, won't every point on that ring produce dB vector? Every point will produce that dB vector. So think about it. That dB vector will also rotate like this. This is my vertical axis. The dB vector will be all around it. Which components will cancel, guys? Think about it. That red vector dB due to every part will be in all around that axis. Which component will cancel? Horizontal, because each dB vector will have two components, horizontal and vertical. Which components will cancel? Think about it. And not about sine, cosine. I have not even marked the angles, Vignesh. It could be sine, it could be cosine, I don't know. Another will take around, I don't know, 4 lectures or something. Yes, the vertical components will add, the horizontal components will cancel, because each vector will have horizontal, vertical. The horizontal, everywhere, tuck, 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 everywhere. It's there equally everywhere. So don't you see all these vectors are equal and opposite, and they will cancel. But the vertical components add, and they will just keep adding. Yes, the vertical components will add, the horizontal components will cancel. Keep this in mind. So I'll just put it over here. This component will cancel, remember that, and this component, okay, this component will add. Okay, now let's mark the angles. Okay, so this is my theta, this is also my theta. Okay, this is my theta, that is also my theta. So the component which will add is dB sine theta. This is dB cos, that is dB sine. Yep. Yes, sure, Pavan, just give me some time. Sometimes I take a little bit time, because off late I have been getting too many messages. My inbox is crowded with 100 messages. It is taking me a lot of time. Okay. Now, what is that total magnetic field going to be? My total magnetic field will be, understand, it will be just the sum of all the dB sine thetas. All the sum of dB sine theta, dB sine theta, dB sine theta, because of every element on the ring. Everybody clear? So, what is the value of dB first thing? What is the value of this dB vector? Oh, just use your Biot Savart's law. dB is mu naught by 4 pi, standard. Mu naught I by 4 pi. DL is this, cross r hat, which is having magnitude 1, into angle between them, 90, sine 90, divided by this distance, which is r square, and into sine theta. Do not forget that, that's sine theta. Well, I'll just put sine theta over here. So what is sine theta? Sine theta is opposite by hypotenuse. That means r divided by small r. Now, bring all the constants outside. Keep this in mind that this value is 1, even sine 90 is 1. Vihan, obviously, once we complete the chapter only, we will have Menti, and Pathfinder Vignesh will be always this timing only. Yes, correcto. Now bring all the constants outside. Let's see what happens. Mu naught outside, I outside, 4 pi also outside. This r square and this r will become r cube. This r will also come outside, and only I will get integral dl. Only Papa dl is inside. Everything else are constants. Oh, by the way, this was x, right? Okay, let's figure out how to get in x as well. Now, what you need to do, what is the integral of dl? Think about it. Integral of dl means adding all the dl's over here. That will give me the circumference. This will be just nothing but 2 pi r. Oh, but which r? Capital R, because this is the radius. Now it is simple to solve. Before solving ahead, this pi goes, this 2 and this 4 goes. So my final answer will be mu naught I, r into r is r square divided by 2 r cube. But this r, this small r, I know guys what to do with it. It's not that difficult to see what to do with this small r. This is hypotenuse, this is right angle triangle. Isn't that small r actually r square plus x square? Isn't that r square plus x square hypotenuse? So you can just write this down as like this, mu naught I r square by 2 r square plus x square whole raised to 3 by 2. That's the net field. Okay, that's what you should know. Standard formula, mu naught I r square by 2 r square plus x square whole raised to 3 by 2. Yes. If the current is reversed, obviously the field direction will be reversed. Instead of being up, it will be down. Magnitude, same, nothing else, no difference at all. So you should know these derivations. If you do not know these derivations, you cannot clear mains, you cannot clear advanced with good percentiles. Obviously, you can clear mains with 90 percentile, but 90 percentile, you will not get any NIT colleges, you will not get any good college. So if you want to just clear for the sake of it, please go ahead, do not by heart or do not remember any of these derivations. But if you want to get into IIT, NIT, triple ITs, BITS, any of these good colleges, you should know the derivations because they might ask something related to the derivation in a question format. Yep, electrostatic deja vu, very good. Correcto. Let's solve a question based on this. The derivation has been put up on the PDF as well. Let's see how many of you can do this. The magnetic field due to a current carrying wire loop of radius 12 centimeters at the center. So if you have a loop and at the center the field is 0.5 10 to the power minus 4 Teslas at the center. Now for that same wire, same loop, if you are 5 centimeters away from the axis or 5 centimeters away on the axis from the center, then what's the magnetic field? Beautiful question, guys. I'll tell you what to imagine over here. See, first of all, you just have a loop and at this point the magnetic field is given to be this one. This is the magnetic field at the center for some current carrying loop. Now what you are doing is you are asking for the same loop at a distance of 5 centimeters. So this 5 centimeters distance is here. What is the magnetic field here? That's the question. So guys, this red path length is 5 centimeters. The radius of that loop is already given to you. This radius. How much is the radius? It's clearly mentioned, 12 centimeters. So I think I know what to do. Arun, it's been almost like a month or so, but you can watch the replays, you can catch up, clear all your backlogs. First things first. What is the formula for magnetic field at the center of a loop? The magnetic field at the center of a loop, the formula is mu naught I by 2r. Remember, this was the formula for the magnetic field at the center of the loop. Now this value is given to me 0.5 into 10 to the power minus 4. So that is equal to mu naught I by 2r. Great. Now for the axis, what's the formula? When you're on the axis, what's the formula? So magnetic field on the axis of the same loop at a distance of x. Remember, I just gave you that formula. It's very similar to this. You just have mu naught I r square divided by 2 r square plus x square raised to 3 by 2. Isn't it? This was the formula. Okay, now what to do, guys? Now what to do? Think about it. We can do something. Yep, I feel we can just use this. We can just use this over here, because mu naught I by 2, look at that, mu naught I by 2 is nothing but this whole thing into r. Look at that. Mu naught I by 2 is 0.5 into 10 to the power minus 4 multiplied by r. How about using this over there? Let's use this over there. I think that will probably help us solve the problem. So that is 0.5 into 10 to the power minus 4. R into r square will become r cube. Everybody clear till this point? So what I have done is I have replaced this part. Remember, I have replaced this part with this. So r into r square is r cube. And what do I have downstairs? I just have, yes, r square plus x square raised to 3 by 2. Now this is simple. I'll tell you why. Because this will be 0.5 into 10 to the power minus 4. R cube. Radius is 12 centimeters. So 12 cube divided by r square plus x square. That is 12 square plus x is 5 square. Whole raised to 3 by 2. Trust me, this is a simple number, because 0.5 into 10 to the power minus 4. 12 square is 144. 5 square is 25. 25 plus 144 is 169. Root of 169 is 13. So all you will get is 12 cube by 13 cube. Because this 1 by 2 is there. The power is 1 by 2. So 169's root is 13. Now you solve that, and I think you should get this as the answer. Yes. Oh, very good question, Rainbow. Don't we have to convert it into meters? A lot of you might be wondering, sir did a mistake. He did not convert centimeters into meters. Guys, I'll tell you what. On the top, you have centimeters cube. At the bottom also, you have centimeters cube. So the dimensions will get cancelled. So that's why you don't have to convert. That's the whole trick over here. So you can avoid that unnecessary calculations which you might end up doing. It will just waste your time. It's not at all needed. Keep that in mind. Okay, beautiful question. So, yeah. No, you don't have to. Yeah, okay. No RS giving. I'm teaching for micro courses, but not for any long-term batch. Okay, great. Actually, like I told, Menti will be only after the completion of each chapter. Next question, then we go ahead to the next one. Okay, there are two coils placed side by side. One coil here, one coil here. At the midpoint, what's the net magnetic field? Two coils each of radius r. What's the net magnetic field at the center? Think about it. How are we going to solve this question? First of all, try to think about the direction. I have told you before this, if there is a coil, curl your fingers. The direction of the thumb gives you the direction of the field. So because of this coil and because of this coil, both of them are in the same direction. That means the magnetic field will be in the same direction. So that means the magnetic field due to each one of them will add. So keep this in mind. The net magnetic field will be magnetic field of first coil plus magnetic field of second coil. But since the question, read the question, they carry same current, same direction, same radius, and this point from the center, this point from the center is at the same distance r and r each. So both these values are same. So I can just say 2 into B1. Everybody fine till here? Everybody fine till here? Shall we go ahead? Let me know in the chat box. Are you guys with me? Are you guys giving up so easily? How many of you guys have given up already? How many of you guys are not going to give up? Let me know in the chat box. Come on, my warriors, do not give up so easily. Yes, we have to add wind bone, correcto. So, what's the magnetic field? Due to any one of them, just calculate it and multiply by 2. That's the standard formula I just gave you. You are on the axis of a coil which carries current. So that will be mu naught I. Okay, mu naught I, remember, divided by 2. Radius square was on the top, divided by r square plus x square raised to 3 by 2. Now guess what? X is center to that point distance, which itself is r. So this thing itself is r. Look at the diagram. You can see that. So now I can solve this easily. But before that, this 2 and this 2 has cancelled. So I'll be getting mu naught I r square divided by r square plus r square. That's 2r square, guys. So 2 r square raised to 3 by 2. This is nothing but mu naught I r square divided by 2 raised to 3 by 2 into r square raised to 3 by 2. This is nothing but mu naught I r square, 2 cube is 8, root of 8. This is root of 8. And r square raised to 3 by 2 is nothing but r cube. Now r square and r cube will get cancelled partially and you will be left with mu naught I divided by r, root of 8 is 2 root 2. That's the final answer. Yep. Yes, both Vikram, both the magnetic fields by both the coils have affected. They are adding. That's why I have put B1 plus B2, because the direction of the currents were same. So since the direction of the currents were same, the fields were adding up. If they were opposite, they would have cancelled. H.C. Verma is the best book, Virat Kohli. I have been mentioning this again and again. You just need H.C. Verma, you just need previous year questions and Tattva module, and that will be more than enough for you to clear. Okay, let's get going. Now the last geometry for today. Come on, my warriors. Last geometry for today, and that is a straight wire. This is how the magnetic field is produced. For the coil, what were your curled fingers pointing towards? Come on, answer in the chat box. Field or current? For a coil carrying current, what were your curled 4 fingers pointing towards? Was it pointing towards the current or was it pointing towards the field? Let me know in the chat box. Think about it. Yeah, for a curved, yeah, for a, no, it's not field, it is current. Remember, for a coil carrying current, you always use the curled fingers for current's direction and the thumb for the field direction. Yes, the thumb was for the field direction, remember. Here, for a straight wire carrying current, the thumb is for the current. The thumb is for the current and the curled fingers is for the field. As simple as that. Now, do you have to remember it separately? No, you always can do it. Come on, by common sense here. Straight wire is like this. What will you put here? Obviously, you can't put 4 fingers like that. Obviously, you will put thumb like that. So, what will curl? The curled fingers. So, if this was a wire carrying current and the current is going up, I will put my finger like this, my fingers will curl like that, so the field is going in this direction. That's it. As simple as that. So it's simple. Yep. Let's get going to the, this is how you're supposed to hold the current carrying wire. Keep this in mind. The field will go like this. Keep this in mind, okay? Yeah, it's circular magnetic field. Okay, circular magnetic field. You would have studied this in 10th standard. Now, there is a very interesting formula for this. if this is a finite wire, this is a finite wire, okay, this is a finite wire and it carries some current, you are at some distance r, and at this point you want to find the field because of this. You can integrate, the derivation has been put on the next screen. The final outcome is what you should remember, guys. You first of all join the ends of the wire. You join the ends of that finite wire. Measure this angle, let's say it is alpha. Measure this angle, let's say it is beta. Then the magnetic field at that point will be given by mu naught I by 2 pi r. R is the perpendicular distance. The perpendicular distance. And just multiply, and do not put actually 2 pi, put 4 pi, and you will put over here sine alpha plus sine beta. That's the final answer. Sabha, at the same time, 7:30 to 8:45 almost. Yep. This is how it is. This is the formula. Remember this. Mu naught I by 4 pi r sine alpha plus sine beta. What is alpha and beta? The angle subtended by the ends of that wire, wherever that end is. How much angle does it subtend? That's all. Correct. Remember this. Now what about the direction? Guys, remember I just told you current is going up. Come on, use your right hand, everybody. Place your thumb in the direction of current. See how the fingers are curling. The fingers are curling like this. So at this point the field is towards you, and at there the field is going inside. So the magnetic field is inside over there and it is coming here towards you on this side. That's all. Okay, cool. Let's get going to some special cases. Okay, this is one of the special cases. This is infinitely long wire. This is infinitely long wire. I want to know, because of a very long wire, what's the magnetic field at a distance r. Now I'll use the formula mu naught I divided by 4 pi r sine alpha plus sine beta. Now can you quickly tell me what's the value of alpha and beta? What's the value of alpha and what's the value of beta for an infinitely long wire? Come on guys, let me know. Ankit, which part you did not understand? Let me know. Direction, magnitude, what? Yes, both are 90 degrees. This will tend towards 90 degrees. This will also tend towards 90 degrees. Both, because the ends are infinitely far away. They are 90. What is sine 90? Isn't it 1? Sine 90. 1. What is 1 plus 1? It is 2. Yes, you will get 2. So you will have mu naught I by 4 pi r. That 2 and this 4 will get cancelled. So you will have mu naught I by 2 pi r. That's for a infinitely long wire. Keep this in mind. Magnitude and direction. Magnitude, this comes via integration, bacha. I have just put up the derivation on the previous slide. Each part will contribute some magnetic field. You add them up. This comes via integration with limits, alpha and beta. So you should remember this formula standard. Direction, just use your right hand rule. Just place your thumb in this direction. See where the fingers are curling. The fingers are curling like this, right? It's going like this. It's going like this. So over there, isn't it going inside? It's going inside. And when it comes here, what is it doing? It's coming towards you. That's how it is. Okay, cool. Let's do some questions based on this. Come on, figure this out. Last 2-3 questions and then homework. Come on, last 2-3 questions. There we go. The magnetic field at the center of the two wires. This wire carries 5 amperes of current. This wire carries 2.5 amperes of current. What is the field exactly at the midway between these two infinitely long wires? Come on, think about it. Think about it. What's the magnetic field? Be careful about the directions. Be careful about the magnitudes. Okay, take each wire separately. Let's start with this wire first. Okay, let's start with this wire. And this wire is carrying current this way. So hold your thumb upwards. You will see the fingers curl this way. So on this side, you can see the magnetic field is inside. Yep, the magnetic field is inside. So what's the magnetic field because of that? Mu naught current, which is 5 by 2, because this is infinitely long, pi, or what is this distance? What is this distance? Half of 5 meters, which is 2.5 meters. So divided by 2.5. Cool. Now look at this wire. This wire also carries current this way. It's 2.5 amperes. Again, hold your thumb in the direction of current. See how the fingers are curling. So again you will see on the left side of the wire, the magnetic field is coming towards me. So that means I should put a dot over here. And again, this distance is also 2.5 meters because it is midpoint. So the magnetic field will be mu naught, but this time 2.5 divided by 2 pi r. Now don't you see that these two will cancel partially? Don't you see, guys, this will partially cancel each other? So guys, that's all you need to do. You have to subtract them. You have to subtract them because this one was inside and this one was towards you. Yeah. So the net magnetic field will be mu naught by 2 pi 2.5, and you will have 5 minus 2.5. Oh, 5 minus 2.5 is 2.5. 2.5 by 2.5 will cancel. So you'll have mu naught by 2 pi, which is option C. That's it. That's it. Understood? Are you getting the hang of these problems? Guys, if you attend the sessions, trust me, with me properly, I will make sure that you are going to crack JEE. And all these lectures are available for free of cost on YouTube. I mean, nobody else is doing this for English medium students. So we have taken up this, you know, what do you say? We have taken this torch of making sure that we are going to enlighten all the students out there, not just English medium, guys. Even if you want to study in Hindi, English, we are always there for you. Make sure that you hit the subscribe button. Make sure you love our videos. Without your support, we cannot grow. Remember that. Let's see this next question. The wire comes like this, bends like that, and comes here. So there are two geometries involved. It comes from infinitely far away distance, bends into a circle, and comes out like that. So the question is, what is the net magnetic field over here? Think about it. Okay. So I feel there are two people at play over here. First is this wire which is infinitely long. Okay. The current is going this way. Now what you need to do, first figure out the direction and then also the magnitude. Hold your thumb in the direction of current. Just hold your thumb in the direction of current that way. Okay. Now your fingers are curling like this. Do you see that? So the field lines will go like that and come from behind and towards you. So at that point, see, the magnetic field is towards me. Yep, because of that wire, it's towards me. And what is the value towards me? Well, it is mu naught I. And what's this distance? Well, it's A. So mu naught I by 2 pi. This distance is obviously A. Well, that's towards you. Next, think about this wire. This is like a loop. This is like a current carrying loop. And the current is going this way. So this time, be careful, curl your fingers in the direction of current. In the direction of current. Where is your thumb going? It's going inside. So because of that, it is inside. And what's the value of that? The value of that is mu naught I but by 2r. R over here is A. There is no pi. Lot of people mistake this formula. They feel there is a pi here. There is no pi over here. Be careful. There is no pi over here. It's just the radius, and the radius is A. So when you find the net magnetic field, okay, when you find the net magnetic field, it will be this minus this, or whatever, whichever is bigger. Obviously this is bigger because there is a pi downstairs. So mu naught I by 2a minus mu naught I by 2 pi a. And which one will that be? Check this out. Is it this one? Option B? Yep, option B, guys. Correct, Winboon? Yes. Understood? Oh? Clear? Oh? Everybody understood? Oh? Shall we go ahead? Yep. Yep. that's how it is. Last question for tonight. Are you guys ready? Let's have a look. The answer is B. Now here's the last question. Two very long wires. One is along x-axis, one is along y-axis. You take a point which is equidistant from both the wires in the first quadrant. D. There is a point. This wire will produce magnetic field. This wire will also produce magnetic field. Question is, what's the net magnetic field? Okay, let's see. Oh, some people have already started answering. Interesting. Ankit, you should study for more than this. You should study for 10 hours. Even if I take a class for 10 hours, you should be like, yes sir, I'm ready. Why? Because you have to study. A lot of YouTubers, I know what they do. They just take small classes. Half an hour class, 40-minute class. We are not like that. We are devoted towards you guys. See, I can do one thing. I can, a lot of people do this. I'm telling you, these are all the inside tricks. They just take the class for 30 minutes, 40 minutes. And in that 45 minutes or something, half the time is like time pass. What happens is they get more views because you are dividing it so many times. Every time you get views. We are not after that, guys. We are after your learning. We are after your benefits. We are after your growth. Understand that. We want to make sure that in one go we complete as much as possible. We want to make sure that you go with that attitude of sitting at a place and studying and concentrating for more than 1 hour, 1.5 hours, 2 hours. That's why we take marathon sessions also. Understand that. Yeah. Chalo. Okay. Let's have a look at this. So this is a wire carrying current. Okay, come on, let's go with the direction. Hold your thumb in the direction of current. The fingers curl like this. Oh, towards this side, because of where did my pen go? And there we go. Yep. So because of this wire, the field will go inside. Yes, the field will go inside. You can see that. Because of this wire, hold your thumb in the direction of current. The field will come, look at that, towards you. So that means a dot. Now the best part is the distances are same, currents are same. Obviously they will cancel. They will cancel, guys. Because current is same, directions are different, distances are also same. That's it. Okay, so understand this. So hence the answer is 0. As simple as that. Else they would have got added up. By the way, this is your homework question. This is your first homework question. Please post up all your answers in the comment section below. And this is your second homework question. Okay, this is your second homework question. Post the second answer as well in the comment section below. And the last question over here, 3 questions. Let's see who is going to do it really quick. Yep, tonight. And remember, guys, if you want to study under me for all the micro courses and all the batches which I'm going to start, so you need to get into micro courses. Not just me, all amazing master teachers are right now teaching in the pro batches. The batches for 12th have already started, and the further you delay your decision, it will affect your end date of the batch. Remember, the virus is here to stay. It's better to take admission right away. And always remember, just studying from YouTube alone is not sufficient. You need to have a combination of both. So that's why we tell you about these pro classes, and these pro classes come with your hard copy material with doubt solving, tests, assignments, and lots of other courses, and you don't have to pay anything extra. This is like your Netflix subscription or Amazon subscription. You get Amazon Prime, you get Amazon Music, everything. You don't pay anything extra, and the prices are as low as 3,060 rupees. And if you want to go for a personal mentor, that's 5,670. But if you just want the doubt app, this is where most of the people go in, 3,870. Now remember, these are all the monthly prices, and if you use the discount coupon code, 10% off on these prices. So that's a big deal, guys. Go ahead. These are really throwaway prices. The link for joining is there in the description box below. Thank you guys for joining in. Thank you guys for tuning in. Without you, we wouldn't be here. And let's make this family grow even bigger. And see you tomorrow for Ampere's law. And remember, there are other geometries like solenoids, toroids, and sheets. We are going to do that tomorrow sharp at 7:30. See you guys. Hasta la vista. This was Shreyas here.